Good evening, Anushka. Good evening, Ashi Patel. Good evening, Saurabh. Good evening, Ankush. Good evening, Snigdha Siddhant. Good evening, Shlok. So, I'm going to introduce you today organic compound. We have understood the unique nature of the carbon, versatile nature of the carbon, that carbon shows the catenation, carbon has a tetravalency, carbon has tendency to form multiple bonds, and carbon shows isomerism. We'll be doing this separate. This topic is very important, isomerism. So we'll be doing that. Okay. Now today I'm going to introduce the organic compound. Like you must have heard the name of alcohol, hydrocarbon, carboxylic acid, ketone, right? And then we will understand this. But how organic compound came into the existence and who is responsible for the first? Uh, do you remember who was the first person who has prepared organic compound in the lab? Generally, it is thought that the organic compound cannot be prepared in the lab, right? And there was one vital force theory, right? As per the vital force theory, it was believed that the organic compound cannot be prepared in the lab but can only be isolated from the animals and plants. And on the basis of this belief, Berzelius, a leading Swedish chemist in 1815, proposed a vital force theory. According to this theory, he said that organic compounds are produced only under the influence of some mysterious force existing in the living organism, right? And this mysterious force was called as the vital force. But Bohler has proved this vital force theory wrong when he has prepared an organic compound, that is urea, from inorganic source. What was the inorganic source? He has prepared urea from ammonium cyanate, and it is a inorganic compound. So, as per the vital force theory, organic compounds can be produced only under the influence of some mysterious force existing in the living organism, right? And then they have called this force as a vital force. But who has proved this theory wrong? Friedrich Wöhler in 1828. He was a German chemist and made an interesting discovery. He accidentally prepared urea from a well-known, or it is a well-known organic compound. And from where he is isolated? From the urine of a man and a mammals. He prepared urea by heating an aqueous solution of two inorganic compounds, that is ammonium chloride and potassium cyanate, and double decomposition reaction takes place and another inorganic compound, ammonium cyanate, was formed. And when ammonium cyanate, it is being unstable on further heating, underwent a rearrangement of the atom, and it was found that he has prepared urea from ammonium cyanate, and which is an unstable compound. So when you further heat it, obviously you will get urea. Understood? So who is responsible for the discovery of organic compound can be prepared in the lab? So Friedrich Wöhler. In which year? 1828. He was a German chemist. And this experiment was conducted accidentally. He found accidentally. It was thought that it is not possible. But he prepared accidentally urea in the lab. And there was only rearrangement of the atom. He could prepare urea from inorganic source, that is ammonium cyanate. Understood? So so organ and what is organic chemistry? We know that study of carbon and carbon compounds is known as organic chemistry. And organic compounds are the living constituent of all living organism. We can't survive without organic compounds. When you see the basic composition of any living organism, whether it's a plant, animal, we know that we are made up of what? So if and what is the basic constituent particle? We know in the last till the last class we understood carbon is the main responsible. Then if you need to draw the electron dot structure of this, and how carbon can become stable by sharing 4 electron, right? Since carbon is able to form 4 covalent bond. Why? Because carbon is having 4 electron in the valence shell and it needs 4 more electron. Until the last class we also understood that carbon cannot form cation or anion. Understood? So carbon is tetravalent, this to know. Now if I say what are the main characteristics of organic compound, right? Now uh, compound like urea, sugar, oil, fat, dyes, protein, vitamins, which are isolated directly or indirectly from the living organisms, such as animals, from animals or plants, were called organic compound. And this branch of chemistry which dealt specifically this and with the study of compound was known as organic chemistry. And on the other hand, compounds like common salt, marble, alum, potassium nitrate, copper sulfate, lots of salts are there, and they are isolated from non-living sources. They are isolated from the non-living sources such as rocks, minerals from the earth crust, right? And it was known as inorganic compound, right? When I say what are the main characteristics of organic compound, so they are non-polar covalent compound. Like if you remember in the acid base and salt, when we have taken glucose, which is an organic compound, and ethanol, which is again an organic compound, do not dissolve in the polar solvent, and they are the poor conductor of electricity. And the bulb was not glowing when they have used ethanol and glucose. Why? Because they are non-polar covalent compounds and they are not going to give rise to ions. Since ions are not there, they are not going to, right? So non-polar organic compound cannot dissolve in water because water is polar and organic compounds are non-polar, right? If you try to dissolve oil in water, it is not possible, right? Why it is not possible? Because water is a polar. You can see water is a polar. So remember the rule, like dissolves like. Organic solvents can dissolve, organic substances can dissolve in organic solvents, and inorganic substances can dissolve in inorganic. So that's why sodium chloride can be dissolved in water, because water is what? Inorganic solvent. And carbon disulfide is organic solvent. Ethanol is an organic solvent, right? So remember the rule, like dissolve like. So remember, inorganic substances can dissolve in inorganic solvents, and organic substances can dissolve in organic solvents. Understood, class? Now next, they have low melting and boiling point due to what? Weak intermolecular force of attraction, right? So we have understood this. Then they have this also. Why? Because when you see they are not having a strong electrostatic force of attraction, as we have observed in case of ionic compound between metallic ion and non-metallic ion, but they are having weak van der Waals forces of attraction. Understood? So they react slow than the ionic compound, right? Their reactivity is slow. They do not react violently. But ionic compound, due to the strong covalent bonds between the atom, what? Now we see the next. Now you can see it is a strong, weak, strong. It means carbon-carbon bond is strong, but the carbon when attached to the another elements, that bond is not strong. So that's why they have low melting point. The carbon-carbon bond cannot break, but the carbon, if attached to some other element, that will be weak bonds. Carbon and other element bond will be weak, and that can be break easily. That's why they have low melting point. But when you see the ionic compound, they have high melting and boiling point. Understood? Then just now we have seen that they react slower than the ionic compound due to the strong covalent bond between the carbon-carbon atom. See, carbon-carbon atom is a strong bond, so they cannot be break easily, right? And due to that, since the bond, what is actually chemical reaction? Breaking of the old bonds and making of the new bonds. Since these bonds, carbon-carbon bonds are strong, so obviously they will take time to react, and that's why there is a strong covalent bond between carbon-carbon, so obviously they will take time. And but in ionic compound, the ionic bonds can be can be break by melting or by dissolving that in the water. The ions will become free, right? Now the next, if you see the 2D structure of the bonding pattern, carbon is found in the center. Short line represent the pair of electron. Just see, you can see this small short lines, this shows the pair of electron. Because if you see, when methane is formed, right, we make a 4 single covalent bond, or carbon tetrachloride is formed, four single covalent bond. If in any organic compound, if you see these four small these small lines, short lines, these short lines are representing one pair of electron. Understood? Now you can see with each pair of electron means the four hydrogen atom can be seen. Can you draw the this bonding structure for methane, chloroform or ethane? Yes, class. Can you tell me? Can we draw this? So let's draw that. So they said ki methane, CHCl3 and ethane. So let's draw that. Yes, Priya, what happened? So we can draw methane like this. We can draw this. I'm not asking understood, not understood. I'm asking please, can you draw this? Yes. And then they said what? Methane and ethane. So ethane to is very easy. And each this short line is representing one pair of electron. Each. Okay. So now you can see if there are two carbon atom and each short line is representing what? One pair of electron. It means they are sharing one pair of electron. So this is actually what? Ethane. And the previous was, this was methane. This is methane and ethane. And then they have asked us to draw, CHCl3. So CHCl3. Once again, every time carbon is going to make four bonds. So we can easily draw this CaCl3. You can see small lines. It means Cl. Okay, good. Good, Priya. Wonderful. And there is no method through which you can show me. Hana, Priya? Oh, sorry. I have made carbon tetrachloride. So we will attach one of the hydrogen atom. So this is CaCl. Every time one short line is representing one pair of electron is shared between the atoms. Right? Because carbon is tetravalent. So carbon can form four bonds every time, four single covalent bonds. So let's go back to the presentation. So we understood how we can draw that. So we can see like this, it is drawing. We have done this in the same manner. We have done CHCl3 can be drawn. And then for ethane, since there are two carbon atoms and each single line is representing one pair of electron. If you find two single lines, it means Priya is laughing. If you find two single lines, so it means they are sharing two pair of electron. Right? If you find three single line between two carbon atom, it means they are sharing three pair of electron. Understood? Remember, carbon has four bonding sites. Always it will form four bonds. It can never form 8 bonds or like that. Like if you see the single bonds, we can see the single bonds also. This is single bond, right? And if they are sharing one pair of electron, it means they are going to form single. So let's see. If there are two carbon atom also, now how double bond can be formed? Vanchika Kushwaha. Now you can see carbon atom can share double bond also. Why? Because they can share they can make double covalent bond also by sharing two pair of electron. Right? It is possible in case of only alkenes. This is possible only in case of alkenes. Now we can see these are the two carbon atom and they are sharing two pair of electron among themselves. Can we see that? And they can also form triple covalent bond. They can also form triple covalent bond. In the last case we have seen they were sharing two pair of electron. You can see they are sharing two pair of electrons. So that's why they were making double covalent bond, and this can be represented by double line, double hyphen. Understood? Now in this case we can see they can share three pair of electron. It means they will going to share three pair of electron each carbon atom. So that's why we can see the triple single lines, or you can see the triple hyphen, right? Then what type? Now we will come to the simplest compound. What are the simplest compound? Do you know that? If I say organic compound, and what type of organic compounds are the simplest compound? So hydrocarbons are the main one. who can be treated, they can be treated as the simplest the organic compound. So if I ask you, okay, what is organic compound? The compound of carbon, compounds of carbon containing usually hydrogen, one or more than other elements such as oxygen, nitrogen, sulfur, halogens, phosphorus, etc. are called organic compound. If carbon is attached with the hydrogen is common, carbon hydrogen is common. But if one more other element is also present, for example, if oxygen is present or nitrogen is present along with carbon and hydrogen, then sulfur is present, then they are going to make different variety of organic compound, right? So if I say the which type of organic compounds are the simplest organic compound, so we know these are what? Hydrocarbons. Hydrocarbons are what? Hydrocarbons are the simplest organic compound, and since name is hydrocarbon, it means it is composed of only two elements, it contains only two elements. And we know that saturated compound is what? Whenever we say saturated compound, so they will always have four bonds. It means the carbon has completed its there is no free electron left behind the carbon. Likewise, in saturated hydrocarbons also you can see that like methane is saturated hydrocarbon, and saturated hydrocarbons are also known as alkanes. Here we can see it is saturated, no free electron. But an unsaturated hydrocarbon, you will see either double bond or triple bond. It means they are sharing two pair of electron or three pair of electron. If they are sharing two pair of electron between them, they are alkenes. If they are sharing three pair of electron, it means they are alkynes. So ethene is the simplest example. So we can see how ethene can be formed. You can see ethene can be formed by sharing two pair of electron. Okay, so it is unsaturated hydrocarbon. Why unsaturated hydrocarbon? We can see the two electrons, they are sharing two pair of electrons, so if they have free electrons, right? And if they can further add any other atoms, if they want to add any halogen, or if they want to add any chlorine atom or bromine or any halogen or hydrogen atom, then they can undergo a hydrogenation, they can undergo halogenation. Why? Because they have free electron. It means they are unsaturated hydrocarbon, and that's why unsaturated hydrocarbon is more reactive than the saturated carbon. Saturated hydrocarbon is what? They are inert because all four electrons are already satisfied. Its octet is completed in case of carbon atom. So since there are single covalent bond, there is no free electrons, it means they are inert, they are unreactive. But when you see the unsaturated hydrocarbons, since there is a presence of double bond and triple bond, they are very reactive. So we can see how ethene can be formed. If you want any hydrogen atom in the ethene, it is possible. That is known as hydrogenation. If you add one hydrogen molecule in that, we can see since each carbon atom is sharing two pair of electron, it means one electron from each carbon atom we can make free, and two hydrogen atom can be attached, and then as a result it is going to form ethane. Carbon atom bonded by the single, like alkanes, yes, they are always attached with a single bond. Now if I say what is a homologous series, first of all, before going to that, I would like to ask you something. Okay, if I say, if can you draw the ethane structure? Just now we have drawn the structure of ethane where two carbon atoms were there, right? Two carbon atoms were there and they were attached with what? Single carbon atoms, right? And when you draw the electron dot structure, what we are going to observe that each carbon atom, there are two carbon atoms, they are sharing one pair of electron, right? And that's why they are saturated, right? They are saturated hydrocarbon. But when I say ethene or ethyne, they are sharing three, in case of ethene they are sharing two pair of electron among themselves, and then they are free, they have free electrons. And ethyne, there is three triple covalent bonds, right? So we can easily see that if you draw electron dot structure of alkane, so you will see between carbon atom there will be one pair of electron. If you are going to draw alkenes, it means there is a double bond between two carbon atom, you will find that there is two pair of electron, right? Like in this case we have already discussed, you can see they are sharing two, and that's why double covalent bond can be seen. So if you want a homologous series of these, right, compounds, how we can make the homologous series? How we can make the homologous series? Right, suppose I am talking about only saturated hydrocarbon, we will start a series with the simplest hydrocarbon, that is methane. If we want to make a homologous series of alkane, we will always start with the simplest one. A series of organic compound which contain a same, let's see first this. Now, organic compound can be classified into group with related to their structure and properties. Like we can classify it on the basis of this similar structure. We can classify alkane. If you find double bond between two carbon atom, we can classify this as alkene. If you find triple bond, then alkynes. If you find OH is attached, then it is this thing. So let's see some example. Suppose hydrocarbons are organic compound that consist of only carbon and hydrogen atom, right? And this is the first method. This is the first member. Now you can see every time one CH2 group is going to increase. This will be the second member. This will be the second member, right? Carbon and hydrogen are there, that is common, we know that. But when you draw the first member of methane, first member of hydrocarbon, that is saturated hydrocarbon, so we can say methane can be drawn like this. Now, if I say how to give name to the homologous series, so it depends upon how many carbon atoms are present. So, what is the length of the carbon atom? Length of the carbon atom can be decided by how many carbon atoms are present in that. We know that meth means one carbon atom, eth means two carbon atom, prop means three carbon atom, but means four carbon atom, pent means five carbon atom, hex means six, hept means seven. We have understood in the class 9th also, I have told you. Okay, so now we can easily define what are saturated hydrocarbon, what are unsaturated hydrocarbon. So if I say what are saturated hydrocarbon? Compounds of carbon which have only single covalent bond. They have only single covalent bond, and between the carbon atom are saturated hydrocarbon, right? And all members will have general formula of what? CnH2n plus 2. What will be their general formula? CnH2n plus 2. Okay, and obviously they are the simplest member of the hydrocarbon family. They can contain only carbon hydrogen, because name itself shows that they are made up of only two elements, that is hydrocarbon. Okay, contain only hydrogen carbon, and what is common in them? They will be having same general formula, CnH2n plus 2. It means twice as many hydrogen atom as carbon and plus 2. Understood? Now, on the basis of this general formula, you can decide the molecular formula of the homologous series of alkanes. Right? If you know this formula, you can easily find out what will be the formula of the next member if you know the number of carbon atom. Right? Suppose you have to give me answer. If I say n value is 4, what will be the formula of the compound? If n value is 4, so what will be the formula of this compound? If n is equal to 4. I am shifting till the time you can. Or a saturated hydrocarbon with contains 5 carbon. I'm changing this. If a saturated hydrocarbon contains 5 carbons, then what will be the formula? You know the general formula, that is CnH2n plus 2. So if you take a saturated hydrocarbon where you find 5 carbon atom, so what will be the formula of that? You know the general formula? Hurry up, class. I'm waiting for your answer. Priya. Don't know? Very easy. CnH. So, yes. C5H12. Wonderful. Priya and Snigdha Siddhant has given C5H12. So, C5H12 is the answer. A saturated hydrocarbon contains 20 carbon. What will be the formula? A saturated hydrocarbon contains 20 carbons. N value is 20. So, apply N value 20 in the formula. So, 20 40 plus 2. It means what? Hurry up, class. Tell me. Very easy, beta. 40 plus 2. 42. Understood? C20H42 is the correct answer. Okay? C20H. So understood? Saturated means wherever you see S stands for saturated, S stands for single bond. This is a link through which you can understand, you can remember. If I am saying saturated, it means there will be single bond. Now what will be the first member? I know if you have one carbon atom, so first member of homologous series of hydrocarbon, like we have understood, the formula will be CnH2n. The first member we can see methane is there, and for one carbon atom root word is meth for one carbon. So meth plus Ne will be the first. It means methane will be the first member. Then if there are two carbon atom, eth plus Ne, so ethane will be the second member, right? Then propane, then butane, pentane. So these are what actually? These are what? These are the members of the homologous series, and homologous series always have a series of organic compounds, starts from the simplest to complex, and every time we will add one CH2 group in that. Understood? What I will take homologous series separately. I am just adding in that. Now when you see, the smaller the compound, it will have lower boiling point and melting point, because I told you what will be the difference between two consecutive members of alkanes. So there will be difference of one CH2 group. If there is a one CH2 group difference, obviously how much mass is going to be added? Every time 14 U mass will be added. C means 12 and 2. 2 means 2. So 12 plus 2, 14 U. So if you move from top to bottom, every time one CH2 group is going to add, means what? The mass is also going to add in that, and as a result they'll be having what? They'll be having more molecular masses. They are going to have more molecular masses. So you can see that's why when you smaller the compound, they will have lower boiling point and melting point and less bonds to break. And the complex the compound, it means they have more number of carbon atom, the long chain will be there, and it will have higher boiling point and melting point. Understood? So we can see that you have to name this how we can name organic compounds. So organic compounds are the name according to the IUPAC, that is International Union of Pure and Applied Chemistry. This is the system of the nomenclature, right? So alkanes always ends in ane. We know that ane, and alkenes always ends in ene, right? And alkynes always ends with yne. This is very easy to give the nomenclature to alkanes, alkenes and alkyne, because you just need to add what? Root word plus ane, so it means alkane. Root word plus ene means alkenes, and root word plus yne means alkyne. So now we can see alkynes. Alkynes are what actually? The series of unsaturated hydrocarbon having one double bond. How we identify any alkenes? Alkenes can be easily identified by this double bond between two carbon atoms. If you find double bond between two carbon atoms, then we can see what are these. These are alkenes. Series of unsaturated hydrocarbon. Why we are saying unsaturated? We can see there are two carbon atoms are sharing two pair of electron. So and this is common name is what? Ethylene. If I say ethene, so ethene common name is what? Ethylene. Now one more thing, if you want to start a homologous series of alkene, it cannot start with methane, because what is the basic requirement for this? The basic requirement for alkene, there should be minimum 2 carbon atom, and there should be double bond between 2 carbon atom. There should be double bond between two carbon atom, right? So obviously the root word meth means what? One carbon atom. So methane is not possible. So it means the homologous series of alkene will always starts from ethene. So ethene will be the first member of homologous series of alkenes. Understood? And their general formula is CnH2n. Okay, so homologous series you can see always starts from ethene. You can see C2H4, right? Ethene, C3H6, propene. Every time CnH2n. And what is there? Every time one CH2 group will be added in that. Okay, one CH2 group will be added in that. Now, let's go back. If I say butene, so this is the one butene, because double bond between is their first and second carbon atom, right? You can see first and second carbon atom is having butene, right? Now we can see pentene. Pantene is having what? We can see either we can have one pentene and two pentene also. We can have one pentene, two pentene also. Why? Because when you see the first double bond is present between first and second carbon atom, then in the second case you can see double bond is present between second and third carbon atom. Second and third. So it is first one is one pentene and the second one is two pentene. What are these actually? Pentene 1 and pentene 2 both are isomers. Like if you remember, I have told you isomerism. Carbon has a very unique property, isomerism. What are isomers? Organic compound which have a same molecular formula but different structural formula. We can see the presence of double bond. You can see the position of the double bond is different in both the cases, but both are having same molecular formula, right? But the position of the double bond is different. In the first case you can see the double bond is present between first and second carbon atom. Then in the second case you can see double bond is present between second and third carbon atom, but both can be represented with the same molecular formula. So we can say that isomers are what? Now let's see. Molecule have same molecular formula but have different structural formula can be taken as a isomers, right? We have seen in this case. Now the third category is alkyne, a series of unsaturated hydrocarbon that contain one triple bond, and also called the acetylene series. Like that was known as ethylene and this is acetylene. Okay, and the general formula is CnH2n-2. And what is common in all alkynes? They should have triple bond between two carbon atoms. The simplest alkyne will be ethine, because eth means what? Two carbon atom, and yne means what? Triple bond between two carbon atom. You can see that. So the first member of homologous series of alkyne will be ethine, and the second will be propyne, and they can be represented by which general formula? CnH2n-2. Understood or not understood? Okay. Now there are some alkyl groups also. They will have one less hydrogen than the corresponding alkane. Suppose if I say methyl. So what is methyl? Methyl means one hydrogen is less in comparison to methane. Methane is having formula CH4 and methyl is having CH3. It means one hydrogen is less, and that's why it is alkyl group. It means alkane minus one hydrogen atom, it will become alkyl. And how to give naming to alkyl group? So root word plus yl. It means one carbon atom, yl means meth plus yl, methyl. If there are two carbon atom, right? And then what will be the formula? C2H5 means if you see what is the formula of ethane? Ethane formula is C2H6. If you remove one hydrogen atom, it will become C2H5, and root word for two carbon atom is eth plus yl means ethyl. So very easy. Now we can see one hydrogen atom will be less in comparison to, if we remove one hydrogen atom, it will become alkyl group. It will not be now saturated hydrocarbon. Okay, and then you can see, can you draw methyl? Yes, we can draw methyl. So this is what? Methyl. We have removed one hydrogen atom from the methane, it will become alkyl group. Likewise, ethyl. Likewise, we know the ethyl. Ethyl means if you draw ethane, ethane means C2H6. If you remove one hydrogen atom, we can see that it will become ethyl, root word plus YL. You have to remember this, because while giving IUPAC name, you should know if some alkyl group is attached, how to give naming, right? So you should know what is methyl, ethyl, propyl, butyl, pentyl, hexyl, like this. Okay, so if I remove this hydrogen atom, so what is going to happen? It is going to become, likewise propyl is also there. Propyl is means what? Propyl, one less hydrogen than propane. Propane formula is C3H8, but the propyl formula is C3H7. So if you remove one hydrogen atom from propane, it will become a, right? Now I will show you isomerism also. How much time is left? Only 10 minutes. This we have already done, no? Yes. So now the very important portion, we have understood something related to the hydrocarbon. The hydrocarbon show what kind of isomerism. You know that. Just now we have seen in case of alkenes, we have seen isomers of pentene 1, pentene 2. Why we were saying those are isomers? Because we have seen the position of the double bond was different in comparison to both, right? So the organic compound having same molecular formula but different structures are known as isomers. This phenomena is known as isomerism. This is very, very important, right? So we should understand very nicely, because in the board examination, they were saying, let's draw. Now, how many types of isomers are there? There are two types of isomers. One is structural isomers, and another is stereoisomerism, right? When you see the structural isomerism, it can be further divided into chain, positional, functional, ring chain, metamerism, tautomerism. We'll try to understand the meaning of each, right? So chain, positional, functional, ring chain, and metamerism. So the type of isomerism is classified basically into 6 types. One is chain, positional, functional, ring chain, and metamerism. First we will understand, because we have to understand chain isomerism, which is present in the what? These are there, which is present in the alkanes, right? In saturated hydrocarbons are showing chain isomerism. Why they are showing chain isomerism? Because we know that carbon is attached with a single bond, right? So how they can show if they are attached with a single bond? In alkene we can show the different position of the double bond, but in alkane we can't show the different position of the single bond, because everywhere there is a single bond. So how we can represent the different structure? Obviously by, changing the position of the carbon atom. If we attach carbon atom in the branch chain, it will become a new structure. And that's why we can see in the hydrocarbons, or specifically saturated hydrocarbon, chain isomerism is present, where what we are doing, we are changing the position of one of the carbon atom. We are putting this carbon atom into the chain form, the branch one, right? So we can see the isomers. There is in our syllabus we have to study the isomer of butane, pentane, and hexane. So we can see in this case, you can see the carbon atoms are attached in the straight chain. Molecular formula of both the compound, that is 2-methyl propane and butane, both are having same, but we can see both are having different structure. Molecular formula same, but different structure means isomer. But why this is categorized as a chain isomerism? Because here you can see we can't show the bonding variety, because here carbon is attached with a single bond, because this is the characteristics property of saturated hydrocarbon. So what we have done, we have taken 3 carbon atom in a straight chain, and 4th carbon we can attach on this carbon atom. So it means what? This is butane, and since carbon attached in a straight chain, so this is N-butane. This is N-butane, and since in this case we can see carbon attached in a straight chain, but on the second carbon atom we can see one methyl group is attached. Just now we have understood what are alkyl groups. One hydrogen less than the alkanes. So if it is 1 CH3, it means it is methyl. If it is C2H5, then it will become ethyl. If there is a C3H7, it will become propyl. Okay, so we can see one methyl group is attached in the second carbon atom. What will be the IUPAC name of this? 2-methyl, because it is attached in the second carbon atom. So 2-methyl propane. Why propane? Because 3 carbon atom are attached in a straight chain. So root word for 3 carbon atom will be prop, and since they are attached with a single bond, then Ane. So what will be the IUPAC name? 2-methyl propane. We can't make more isomer from butane because this is the only arrangement of the atom we can show. Either carbon-carbon atoms can attach in a straight chain, or it can be in the branched one. So the first isomer of this, where the carbon-carbon attached are attached in a straight chain, are what? N-butane. What is the name of this isomer? N-butane, because this is the normal chain, right? So that's why N is representing what? Normal. So this is N-butane, the first one. And the second one, since one methyl group is attached on the second carbon atom, so second isomer will be known as isobutane. The second isomer will be known as isobutane. Understood? Likewise, in alkene, we can see positional isomerism. Position, just now I have shown you in case of pentene 1, pentene 2. What was different? The position of the double bond was different. In this case, we can see the position of the double bond. Here in the first and second carbon atom, we can see the double bond. In the second case, we can see second and third carbon atom double bond is present. It means they are showing the position of the double bond. So they differ in the position of the same functional group. Since there is a double bond, it is representing the functional group, same functional group, but their position is different. And both are having same molecular formula. What will be the butene formula? C4H8. C4H8 will be the molecular formula, and since they are showing the different positions, so we can see that they will show the positional isomerism. Understood, class? Then functional isomerism. There is a one exemplar question. They have given the formula of this, and the same question was asked in the board. The same question was asked in the 2020 board. Then they have given the molecular formula, and then they have asked whether they are isomer or not. So they are two isomers or not. Okay. So in the functional isomerism, we can see they are having same molecular formula, but they differ in the nature of the functional group. In this case, they are having C3H6O2. The molecular formula both are having same. C3H6O2, both are having same molecular formula, but in this case we can see what? Carboxylic acid is present. In the next case we can see ethanoate, it means ketone is present, right? Which functional group is present in the second case? Ketone, and ketone is always represented no, it's not a ketone, it is a ester, right? So we can see one is representing ester and the next is representing carboxylic acid. So both are having different functional group, but they are having same molecular formula. Since both are having same molecular formula, but their functional group is different, and that's why they are representing functional isomerism. Understood, class? So thank you. I'm going to end my class here. Thank you very much. God bless you all.